Much of our work in this unit will concern adding the terms of a sequence. In order to specify this addition or summarize it, we have a new notation known as summation or sigma notation that represents these sums. So summation is what we're doing. Sigma notation is the symbol sigma, and that's a Greek alphabet letter. So we have this new summation. It looks like an E. I is our variable, and A is the first term or the first number we are plugging in. N is the last number we're plugging in, and then we have some expression here, so some function of I. We have to start at A and substitute in for I until we reach N, and that probably means nothing to you. So let's do an example so it makes a little sense. So we have the summation, and our variable is I, and I equals 3. Our expression is 2I, and please put this in parentheses, and our last number is 5. So the way I like to think about this is we're going from the third term to the fifth term. So we have to plug in I equals 3 into this expression of 2I. Then we have to do I equals 4, and then we have to do I equals 5. So we have to add all of these up, so 6, 8, and 10, and this E means summation, so we're summing these numbers, we're adding them all up. So 6 plus 8 plus 10 is 24. So the sum from I of 3 to 5 of 2I is 24. All right, letter B. So now in B, we have 5 plus the sum from 2 to 5 of 2 raised to the j minus 1. So they changed our variable. And you'll notice in all of these, they mostly have different variables. All right, I'll tell you, I'm prefaced. My preference is the variable n or x. So when I write them, I use n's or x's. But you can use any letter you want. So I'm doing the summation from 2 to 5. So I'm going to take 2, and j is 2 minus 1. When j is 3, it's 2 to the 3 minus 1. When j is 4, it's 2 to the 4 minus 1. And when j is 5, it's 2 to the 5 minus 1. So go ahead, pause the video, find those 4 values. Now here's the catch. We have to, when we're done finding the sum, add 5 to it. So let's first find the sum, 24, 28, 30. Now we have to bring this 5 plus down. So 5 plus 30 is 35. So the sum of 5 plus the summation from 2 to 5 of 2j minus 1 is 35. All right, so letter C. Now we have the summation of a equals 4 to 7 of a of x plus a. Ooh, we have an extra variable in there. We don't know what x is. So when a equals 4, we have 4x plus 4. When a equals 5, we have 5x plus 5. When a equals 6, we have 6x plus 6. And when a equals 7, we have 7x plus 7. And we are adding all these up. You don't have to write this part down. I do just to help me remember. So 4 plus 5 plus 6 plus 7 is 22 plus 4 plus 5 plus 6 plus 7, now with the x's on them, is 22x. So the answer to this one is 22x plus 22. All right, let's try a you try. So pause the video, and why don't you try letter D? There isn't an extra variable. Why don't you try the whole row? And then continue the video to check your answers. All right, here's the answers to the you tries. That last one, F, is pretty tricky. So if you didn't get these answers, please make sure you ask in class, especially these letter C and letter F, where we have those extra variables. Those are the really, really tricky ones. Now, we've done 6. Here's the truth. You can check these in your calculator, of course. So grab your calculator. So the summation button is next to the number 9. This is our template button where we have our piecewise. We can do another place to find log, e, any radical, square roots, any exponent, fraction. Oh, look, absolute value. And then you can see highlighted already is our summation button. So the cool part is all we have to do is plug it in. So in letter A, it said I equals 3. So I fill in the boxes. My expression is 2I, and my top number is 5. Hit enter, and my answer is 24, which notice is exactly like what I got. So you can check your work. When you have extra variables, you're going to have to store a value for that extra variable to do a check. So if you want me to go over that, please make sure you ask in class tomorrow. So the second one, we would do 5 plus and hit our summation button. We have J equals 2. 2 raised to the J minus 1 of 5. Hit enter, and you get 35, which is exactly what we got when we did our longhand, right? So using the calculator is important, like exercise 2. So why don't you try exercise 2 on your own, and then continue the video to see if you got it right. Of course, use your calculator. You should have gotten an answer of choice 3. And this is what it looks like in the calculator. Exercise 3. Consider the sequence defined recursively by a sub n equals a sub n minus 1 plus 2 times a sub n minus 2. So remember, this means some term equals the term before it plus 2 times the term before that term. And a sub 1 is 0 and a sub 2 is 1. Find the value of a sub, or the summation from 4 to 6 of a sub I. So what does this mean? Well, I plug 4 in here for I. So I sub 4, or not I sub 4, a sub 4, a sub 5, and a sub 6. The E means I sum them. So I need the 4th term, the 5th term, and the 6th term. I only have the 1st and the 2nd. So I have to do some work beforehand. So the 3rd term is the 2nd term plus 2 times the 1st term. So a sub 2 is 1 plus 2 times 0. So my answer is 1. The 4th term is the 3rd term plus 2 times the 2nd term. So 1 plus 2 times 1, which is 3. The 5th term is the 4th term plus 2 times the 3rd term. So the 4th term is 3 plus 2 times the 3rd term, which is 1. And the 6th term is the 5th term plus 2 times the 4th term. So the 5th term was 5 plus 2 times the 4th term is 3. So my answer is 11. So the 4th term is 3, the 5th term is 5, and the 6th term is 11. So 3 plus 5 is 8, plus 11 is 19. So the sum of this is 19. That's crazy. That's a very difficult question. So make sure you take the time to look that one over. All right, it's also good to be able to place sums into sigma notation. These answers, though, will not be unique. Express each sum using sigma notation. These are pretty standard directions. So the E is the sigma notation. It's telling us to use I as your index variable. Normally it doesn't tell you. You get to pick any one you want. So first consider any patterns you notice amongst the terms involved in the sum. Then work to put these patterns into a formula. Well, here's the coolest part. You already know how to do this. So letter B, I have my summation. I'm going to start with I equals 1 because -6 is my first term, second term, third term, fourth term. I don't know what term, so that goes on the top. What's my formula? Well, what am I doing to this? Am I adding or am I multiplying? Well, I am adding 3, so my common difference is 3. So I'm using the same formula. My first term is -6 plus my common difference is 3 times I minus 1. I need to set up 15. So 15, I need to find out what term it is. So 15 equals -6 plus 3 times I minus 1. So -3 or -6 plus 3I minus 3. Combine like terms, -9 plus 3I equals 15. Add 9, get 24 equals 3I. So I equals 8. So this is the 8th term. So grab your calculator. Let's plug it in. So I of 1 equals 1 of -6 plus 3 times I minus 1. Up on top, we want it to the 8th term, so we want from the first term to the 8th term. And your answer is 36. Why is it so low? Well, we started with negatives, so when you add negatives to positive, remember they cancel each other out or they make 0. So that's why our sum is so low. So let's try C. So again, we have a summation. We're going to start with our first term. We don't know what term this is. This was our first, second, third, fourth. We don't know. So we're going to have to do some math to find out. Let's find our explicit formula. So what are we doing? Are we adding or are we multiplying? Oh, I would look at these numbers. I would not, this might not be helpful. So what are you doing to 1 to make 5? You could say adding 4, but I'm pretty sure adding 4 to 1/5 doesn't give me 1. So I am multiplying. So this is an R value of 5. I'm multiplying by 5. So my geometric formula says A sub n equals A sub 1 times R to the n minus 1. So my first term is 1 over 25 times, my ratio is 5, to the I minus 1. Now I need to find out what term number this is. What term number is 625? So 625 equals 1 over 25 times 5 to the I minus 1. So divide by 1 over 25. So when I divide that, I get 15,625. So now I need to make like bases. So 5 to the 6th power equals 15,625 equals 5 to the I minus 1. Bases are alike, so 6 equals I minus 1. So 7 is my value of 625. So 625 is the 7th term. So I put a 7 up there. I grab my calculator. I'm going to put in summation, not that. I have I equals 1. I have 1 over 25 times 5 raised to the I minus 1. And on top I have 7. So I'm going from the first term to the 7th term, and I have this geometric expression. My answer is 19,531 over 25. So it is a fraction. There's nothing wrong with a fractional answer, because look at, I was adding fractions to start with. So why don't you try D and E and continue the video when you're done. D is easy. They tell you 15 terms. Compared to A, B, and C, a lot less work. Hopefully you already did D and E and you got the same answers as I did. If not, please make sure you ask in class. And then number 5, I wrote again the summation, and I found the summation of 93. Then I looked at the choices and I plugged each choice in. Number 1, I got 363, which is not the same answer I got. Choice 2 is, remember, when they write their choices, they can write it in any equivalent fashion. So that's why 2 is the answer, because their sums are equal. So, good luck, and if you have any questions, let me know.